page 543 from 18, and we have the sine of the 222.5 degrees. Okay, we try to use the half angle identity to find it. So here in this 18, we don't find the exact value, we just try to determine the sine of this sine of the 222.5 degrees. So tell me which quadrant this angle is in. Which one? 3, right? And if you are not sure, you may draw a sketch of this angle. You know this 222.5 degrees is bigger than 180, right? But less than the 270 degrees. So definitely this guy is in the quadrant 3, right? So now we know this is negative. In quadrant 3, sine is negative. So you just take the negative sign before this radical symbol, right? So this is problem 18. Now let's look at the problem 20. Cosine of the 9 pi over 7. Okay, let me copy this problem on the whiteboard. So we need to determine the sine of the cosine of the 9 pi over 7. And first, you know this 9 pi over 7 definitely bigger than pi, right? And now you compare this 9 pi over 7 with the 3 pi over 2. Which one is bigger? Which one? And you may use a calculator to compute. 9 over 7 is about 1.3. 3 over 2, 1.5. Right? So definitely this 9 pi over 7 is less than 3 pi over 2. So this guy is less than 3 pi over 2. So you know this 9 pi over 7 belongs to quadrant 3. So that means this cosine of the 9 pi over 7 is less than 0. Now let's look at the problem 33. And we need to use the identities to simplify each expression and do not use a calculator. Okay, let's move to the 33. So now we try to use the identities we have learned to simplify this expression. Let me copy this problem on the whiteboard. So page 543, problem 33. We have the cosine square of the pi over 9 minus sine square of pi over 9. So tell me which identity does this expression remind you? So it's a cosine square x minus the sine square x. Cosine square x minus the sine square x equal to what? What? Cosine of 2x, right? So this guy is equal to cosine of 2x. So this is double angle identity for cosine. So now by using this double angle identity for cosine, we can easily simplify this expression without computing each values. So we have the cosine of the 2 pi over 9. And just leave your answer in this exact form. You don't need to get the decimal. So by now we have learned the half angle identities for sine and cosine. Then we can use it to get the half angle identity for tangent. So let's move to the next page. And let's talk about the half angle identity for tangent. And tangent of half x. So by definition, this is equal to sine of half x over the cosine of half x. And we can use the half angle identities for the sine and cosine. So for sine, this is equal to plus minus the square root of 1 minus or plus. Yeah, for the numerator, it's the 1 minus or plus cosine x minus, right? Remember this? So, and then for cosine half x is the 1 minus or plus, right? So this cosine of half x, just take the opposite sign under this radical before this cosine x, right? So in the case of the sine, we have the minus cosine x. Then in the case of the cosine, we have the plus cosine x. Okay. Now we may use the quotient rule for the radicals. So this guy, let me move here. So plus minus sign. So totally, they can only either take the plus or the minus, right? So we just put them together. And then you have the 1 minus the cosine x over 2 divided by 1 plus cosine x over 2. And then we multiply both the numerator and denominator by 2. So this 2 and this 2 cancel, and this 2 and this 2 cancel. Then you get plus minus the square root of the 1 minus the cosine x over the 1 plus the cosine x. Now, to simplify this expression, and let's multiply both the numerator and denominator by 1 plus the cosine x. We try to rationalize the denominator. And then for the numerator, you have the 1 square minus the cosine x square, right? You have the a minus b times the a plus b equal to a square minus b square, right? So now this numerator is equal to 1 minus the cosine square x. And denominator, this is the square of the 1 plus cosine x. And we know 1 plus cosine x is always non-negative, right? Because cosine x is less than or equal to 1 and greater than or equal to negative 1. So this guy is always non-negative. So we can take this out. You have the plus minus the square root of the sine square over the 1 plus the cosine x.